Hello friends, we're gonna learn about ROM, that is read only memory. Read only memory is a device that includes both the decoder and OR gate within a single IC package. So the connection between the outputs of the decoder and the input of the OR gate can be specified for each particular configuration by programming the ROM. We will see later how ROM is constructed. First of all, we need to know the ROM size, how they measure the ROM. If n is equal to input and m is output, so the actual size of ROM is 2 to the power n into m, where n is input, m is output. And we must remember that the input of this ROM is the output of the decoder. I again repeat that the input of ROM is the output of decoder. So the ROM size will be 2 to the power n into n. So if we see a basic flow diagram of ROM, that is input n and output m. So the ROM is to be 2 to the power n into m, as we see in the previously. If we analyze 32 into 8 bit ROM, we will see that 32 can be written as 2 to the power 5 and 8. And if we compare it to the 2 to the power n into m, we will see that n is equal to 5 and m is equal to 8. So the decoder output is to be 5 into 2 to the power n, that is 5 into 32. It is the decoder output, which is the ROM's input. Okay, now we want to see how a ROM is constructed with logic construction. So I'm gonna read a question. Draw the logic construction of 32 into 4 ROM. First of all, we should analyze 32 into 4, where n is equal to 5, m is equal to 4, 2 to the power n is equal to 32. So the decoder output, decoder is constructed 5 into 32, and now we will implement the ROM with decoder plus out or get. So we will see the construction of that ROM is to be, this is 5 into 32 decoder, and this is A0, A1, A2, A3, A4, A0, A1, A2, A3, A4, which is the input, and output of this decoder is 32. So 0, 1, 2, 3, 4, dot 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 dot. Similarly 31. So the wire should be connected with this pin, and we will be connect every wire with every pin, dot 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 dot, that is 31, let's say. Now we will give OR gate to connect with this wire. Let's say that is 31. So we will see a OR gate. We will denote it with F1, and as the output is 4, so we will construct similarly F2, F3 and also F4. So in that similar way we will construct next F2. So let's say that is 31 also. That is the terminal. That is F2, and you will also need to construct F3 and F4 also. This is the basic implementation process. Of constructing ROM. One thing should be remembered that this is the link by which we can give a connection where we want to desire to connect with the transmission line. Let's say if we want to connect with 6 and 7 transmission line. We need to connect 0, 1, 2, 3, 4, 5, 6. If there is another 2 output is given here, 6 and 7, we need to connect here. Just simply connect these 2 terminals. So this is called the connection line, which is called as link of ROM. Now I want to show you another example, that is F1 is A0 and A1 is mission of 1, 2, 3, and F2 A1 A0 is summation of 0, 2. From this question we will see that here is input is 2, which is called N2, and the output F1 and F2, so M is equal to 2. So here the decoder size will be n into 2 to the power n, which is equal to 2, and 2 to the power 2 is equal to 2 into 4, and the ROM size will be 4 into 2, as we discussed before. So the construction will be two into 4 decoder, which has input only 2, A1 A0, and it has put 0, 1, 2, 3, 1, 2 and 3, and we have output F1 and F2. So we now construct F1 and also connect with a OR gate, which is F1, and we will see the F1 is the summation of 1, 2, 3. So we need to link up with the where and the OR gate also. So here is 0, 1, 2, 3. So we need to connect 1, 2, 3. So we now link up with 1, 2 and 3, and F2 is also connected with 0, 2. So we will see that F2 is connected with 0 and 2. This is the basic example of constructing ROM. One thing should be included, that if there was a question that is to show invert implementation of the ROM, that is, we need to connect the link up where into the invert portion. Here this we need to connect 1, 2, 3 is the summation of F1. So if we see a question to invert implementation, if we see a question invert implementation, we need to connect only 0 in case of F1, and as F2 is the summation of 0, 2, on the invert implementation portion we need to connect 1, 3 and 4. So I just only show you the example. This is the F1's invert implementation. We just connect 0, and we will just add a NOT terminal with this OR gate, that is called F1. As we include a NOT, so ultimately we will see the another 3 terminal will be connected as 1, 2, 3. So whenever we see the F2, as it was the 0, 2 and the invert implementation is 1, 3, 4, we will connect 1, sorry, this will be 1 and 3 because the output is 4, so 0, 1, 2, 3. So the invert implementation is 1, 3, so we need to connect 1 and 3, and we also add a NOT gate to get ultimate result of F2. So this is a tricky question to answer the questions of invert implementation of ROM. On the next tutorial we will see a combinational circuit using ROM which accepts 3-bit number. Until then, goodbye, and please subscribe the channel also to get more updated videos. Thank you.